All right, I hope you just watched the video on section 3.9, number 16, and then that helped you with some of the beginning homework problems. At this point, I'm going to work on section 3.9, problem 24. So if we look at the instructions to problem 24, it indicates in the instructions that we can use a linear approximation or differentials. And the problem on question number 24 is they want us to find an approximate value for the sine of 1 degree. Now, the way we're going to do this problem first, I'll do it both ways, but the way I'm going to do it first is I'm going to use differentials. All right, I'm going to approach this with differentials. I want to find the sine of 1 degree. Now, to do that, I have to identify my function. I've got to identify my x, the value that I'm working near, and I've got to identify my delta x. So I have sine of 1 degree. That leads me to believe that my function is going to be y equals the sine of x, or f of x equals the sine of x. Now for x, we want to choose the value of x that's near the indicated question value, which is 1 degree. We want to choose a value that's near that, something that we know the sine of. Well, near 1 degree, we know the sine of 0. So I'm going to let my x equals 0 degrees. And then I have to calculate my delta x. My delta x is the difference between the x that I know, which in this case is 0, and the x they've asked me to find, which is 1. So delta x here, delta x, which is the same as dx, that's going to equal 1 degree. Now degrees aren't going to do us any good. We're going to have to put that into radians. 1 degree in radians is pi divided by 180. So I'm going to start by identifying my function, y equals sine x. I'm going to identify my known value of x, someplace I know the value of sine, near 1 degree. I can't pick anything. So I picked 0 because that's near 1 degree. And then my delta x, or my dx, which is going to be positive 1 degree, the distance from 0 degrees to 1 degree. And now I'm going to do the problem just using differentials. So I'm going to begin by saying that dy is equal to f prime of x dx. Now we know f prime of x is the derivative of sine of x. The derivative of sine of x is cosine of x. We also know we want to evaluate that at x. X in our problem is 0. So I want to find f prime of 0, which is cosine of 0. Cosine of 0 is 1. All right, so we found that part. We know dx. Dx is pi over 180. So if we plug those in, we get dy equals f prime of x, or f prime of 0, times dx, which works out to be f prime of 0 is cosine of 0 times dx, which is pi divided by 180. Cosine of 0, of course, is 1. 1 times pi divided by 180 gets me that dy is pi over 180. So here's my calculations. You can push the pause button if you want to take a look at those. Now, from the lecture we looked at today in class, we know that the graph of sine near 0 and if we exaggerate it immensely, we know that at 1 degree, the graph of sine is below the tangent line. Graph of sine is below the tangent line. And what we said today in class is we said that dy, the value we just found, dy is the distance from the known y value, which in this case is sine of 0. The known y value is sine of 0. X is 0. So that's 0. Sine of 0 is 0. So dy is the distance from x equals 0 up to the tangent line. and that's pi over 180. Well, since our initial value in this problem is 0, our horizontal line, earlier in class today we had that as f of a. But today, in this problem, that's 0. Sine of 0, our known x, sine of 0 is 0. So we're starting down there. So what we're saying, in essence, is this problem, we're saying that the sine of 1 degree, is equal to our starting value. It's approximately equal to our starting value, which is 0, plus our dy. Our dy is pi over 180. So that's going to be 0 plus pi over 180. That's going to be equal to pi over 180. Now, if we ask our calculator for the value of pi divided by 180, we get 0.01745 to 5 decimal place accuracy. Now remember, we're attempting to estimate sine of 1 degree. So an interesting comparison would be to calculate sine of 1 degree, just to find out how close we've come with this estimation. Sine of 1 degree, if we plug that into our calculator, sine of 1 degree turns out to be, function sine 1 degree, it turns out to be 0.01745 24064. So if you take a look at the actual calculated value of sine degree, and if I round it to 1, 2, 3, 4, 5, 6 decimal places, if you look at the actual value of sine of 1 degree, you see that our estimated value of sine degree, 0, plus dy, is really, really close. So we can use differentials to estimate values. In this case, we estimated the value of sine of 1 degree. Now, I promised to work this out with linear approximation as well. And hopefully, if we work it out with linear approximation, we can get the same result. After all, that's one of your goals, right? To prove that linear approximation and differentials are the same thing. So how would we approach the same problem if we were doing this with linear approximation? Well, remember our linear approximation formula is L of x equals f of a plus f prime of a times x minus a. All right, that's the formula that we have for linear approximation. Now, there's a little bit of change here in the case that our a is going to be 0 degrees. Okay, a is the value we know. That's 0 degrees. And our x is going to equal, in this problem, it's going to be 1 degree. 1 degree. Okay, so the letters kind of change roles here when you do it with linear approximation. Now, to do this problem, we have to find the derivative of f. F is again going to be sine x. The derivative of sine x is going to be cosine of x. And we are going to want, based on that formula right there, we're going to want to find f of a and f prime of a. Okay, and then we have x minus a. Well, if we plug these in, f of a is f of 0, which is sine of 0, which equals 0. Sine of 0 is 0. F prime of a, in this case, is f prime of 0, which is cosine of 0, which equals 1. Okay, cosine of 0 is 1. So, given those two values, and again, you can push pause here if you need to, we can plug them into the formula up above and we can get our linear approximation formula. Okay. Our linear approximation formula is going to be L of x equals f of a, which turns out to be 0, plus 1 times, 1 is the slope, 1 times x minus a. That turns out to be 1 degree minus 0 degrees. And I'm going to just on the fly here convert that into radians. So that's 0 plus 1 times 1 degree is pi over 180 minus 0 degrees, which in radians is just 0. So this is our linear approximation formula. Well, if we work that out, right, we can do the math. We get that sine of 1, according to this calculation, is approximately equal to 0 plus 1 times pi over 180. Well, 1 times pi over 180 is pi over 180. And 0 plus that, so we get 0 plus pi over 180, which equals pi over 180. And we already know what the value of that is. We know that pi over 180 is 0.01745. Now, if we take a look at this, everything we need to convince ourselves that differentials, which gave us this equation right here, okay, this one, turned out to be 0 plus pi over 180. And then down here, linear approximation gave us, well, I'm kind of shocked, but it gave us 0 plus pi over 180. What we got up here for differentials is exactly the same as what we got down here for linear approximation. I admit that the work in the middle looks a little different than the work up here, but the answer in the end, well, the answer in the end is exactly the same, which is probably why in the instructions it says use linear approximation or differentials to complete problems 23 through 28. So I hope this work on problem 24 gets you up and rolling on problems 23 through 28. I'll see you tomorrow morning.